Hi, my name is Peter Stæhr. I am a professor at the University of Aarhus in Denmark, the Department of Ecoscience. At the GuardIAS project, I am representing case study 10, which is on Wakame, also known as Undaria pinnatifida, and it's spread in the North Sea via offshore wind farms functioning as stepping stones. Wakame, which is the common name that you may be familiar with when you eat sushi. It's the green lettuce-looking, delicious, edible macroalgae that has been served many places all over the world. It's become a worldwide invasive species as it has been introduced for agriculture, but also it has been introduced via hull fouling and vessels in general. It comes from Northeast Asia, where it's native, but now it has spread through all of Australasia and most of Europe and the east coast of the United States. So it's one of the top 100 invasive aquatic species in the marine environment. And it's known to displace through competition other larger brown algae. So it's a brown algae that can be up to 1 to 2 meters long. It's very fast growing. It actually has an annual life cycle. So compared to some of the other species that it competes with, it has a much faster growth. It has much more productive. And so it has a negative impact via displacing other foundation species, we say, and while it also has some positive potential impacts, because it's known, as I said, it's an edible organism, but it also has some antioxidants and other health-related things. But then it also is associated with slightly different fauna and flora that is attached to this large algae. So it has some economic positive in terms of the food, but it also has some impacts on the native environments that it's displacing other organisms. We are very interested to see whether this species, which currently is not in Danish waters, it's just south of the Danish waters in the North Sea, whether that species will be facilitated, its spread throughout the North Sea with the establishment of these offshore wind farms that is being planned, this energy, renewable energy source that we're currently planning, like 3 times more of these offshore wind farms in the North Sea. So those will potentially be called, function as what we call stepping stones. So whereby organisms have now suitable substrate, because this organism requires a hard substrate, which could be rocks, intertidal rocks, but it could also be the surface of an offshore pillar that goes in and helps at the seafloor. It has what we call scour protection, though there's different hard substrates that are being introduced all along the west coast of Denmark, and it potentially will then will fill a gap, whereas currently it's soft sediment, because the North Sea is in that region for many hundred kilometers dominated by sandy, muddy areas that used to be covered with the European flat oysters and some reefs that were boulders left behind by the glaciers, but all of these have been removed by significant trawling. But now that we are establishing these wind farms, then you can imagine how an organism can potentially jump from none to another, and that will facilitate its spread, further spread into the Kattegat and the Danish waters, where it could be where we have lots of reefs. So it's about understanding whether these offshore wind farms will facilitate the spread by introducing this hard substrate. So we investigate this with quite thorough modeling. So we have hydrodynamic models that show how the currents are moving, and we use agent-based modeling, and we combine it with understanding of the traits. What are the conditions that has to be fulfilled for this organism to be able to survive? And so we model different scenarios with different densities of offshore wind farms, and then we also do impact modeling. There is an approach that this project is using in many studies called SIMBO. And then also we do a lot of monitoring to see, do we see traces of this organism throughout this area. We also include citizen science in trying to engage local people, because this large seaweed, if it is in the area, then it will also occur on the beaches as it detaches, and then they can visually see it. So there are many components to this study. So it's basically understanding, can it come in, can it impact, and how far will it spread, and understanding the mechanisms. It's a larger process, and in GuardIAS we're using this bow tie analysis that links all the drivers' activities and pressures to the state and the impact, and we're then figuring out, okay, so where can you possibly reduce that impact? There are different stages, and then the next stage is really to look at using an approach called the 10 tenets, where we look at the feasibility of these different approaches. Is it feasible to lower the scour protection? Is it feasible to clean these pylons? Is it feasible to use some kind of hydrophobic surfaces that are being explored? Or is it better to think about compensation, because all of these, it's unlikely that we can do anything, because you have thousands of windmills and you cannot clean them, you cannot do all of this. So this is the next step that we will also be doing, but it's based on the knowledge that we obtain through the modeling and the monitoring. Yeah.